So for this problem, to evaluate the derivative for this given, so first we need to rewrite this radical in exponential form. So this is y then equals 7x minus 5. Then for the exponent, so this 2 is the numerator, then over the root is the denominator. So to the power 2 over 3. Then using now this chain rule formula, so u the equation inside the parentheses, so u equals 7x minus 5, then du, or the derivative of u. So since the derivative of 7x, this one is 7, and the derivative of a constant, this one is 0, so du is equal to 7. Then for n is the exponent, so that's 2 over 3. So since we have now the values for u, du, and n, so we can find now the derivative. So this is y prime equals, from this formula, so we have n, and n is equal to 2 over 3, then times u, and u is equal to 7x minus 5. Then we have n minus 1, so n is equal to 2 over 3, then minus 1, then times du, and du is equal to 7. Then to simplify, so we have y prime equals, so this is 2 over 3, then times 7x minus 5. Now take note that this 2 over 3 minus 1, this is equal to 2 over 3 minus 3 over 3, because 3 over 3 is equal to 1. And to make these two denominators equal, so if we have 4 over 5 minus 1, so we can rewrite this one as 4 over 5 minus 5 over 5 to make these two denominators equal. So therefore, this becomes 2 over 3 minus 3 over 3, then times 7. Then we have now y prime equals, so we can multiply this 2 over 3 times 7, or just multiply this 2 times 7. This one is 14. Then just copy this denominator 3, then times, so this becomes 7x minus 5. Then this 2 minus 3. So 2 minus 3, that's negative 1. And just copy this denominator 3. Then observe, the exponent is negative. So we can bring down, and this becomes y prime equals 14. Then we have 3. Then times 7x minus 5, and this negative exponent becomes positive exponent. Then we can write this one in radical. So we have y prime equals 14, then over 3. Then this is, since the denominator is 3, therefore this one is cube root. Then we have 7x minus 5. So this is now the derivative.